All right, so welcome back to our exponent lesson here. We're taking a look at rational exponents and radicals. So a rational exponent is a exponent expressed as a rational number, so that think fraction there. A radical expression is one that contains a radical symbol, and so heretofore we've known this as a square root symbol, but we can actually have higher roots. So just like the square root of 16 means some number times itself 2 times equals 16, well, we could put a little index there that would say how many times that number must be multiplied together by itself to equal 16. And we could even change that and say some number times itself 4 times equals 16. And the answer to that would be 2. So 2 to the 4th is actually 16. So just like we can have square roots, we can have higher roots, just like instead of squaring things, we can cube them or take them to the 4th or the 5th. We can have greater indices. So before I get too far ahead of myself here, let's take a look at the parts here. So if I have a to the m over n, the top is going to be my exponent, and the bottom is going to be my index. So if I have a radical form, that index goes on the little shelf of the radical there. So there's my n. Now there's 2 ways to write this in radical form. I can say it's the nth root of a to the m, or I can say it's the nth root of a raised to the m. And either way is perfectly fine. One suggestion to help you remember is that exponents are written over index. EOI, exponents over index. So exponents come first before the index. Another way to think about it. So to take a rational exponent and write it in radical form, I like to take the denominator of my rational exponent, pull it off, and write it on the shelf of my radical here. So x to the 1/2 becomes the square root of x to the 1. Or the second root of x to the 1st. X to the 2/3, we're going to do the exact same thing. I'm going to take that 3 off the denominator, pull it around, put it on the shelf to make it the square root of, or the cube root rather, of x squared. Now we could write that a different way. We could say it's a cube root of x, the whole quantity squared. Both are perfectly acceptable. X to the 3/4, go ahead, pause, give that a moment, see what you get. So we should be getting the 4th root of x cubed, or the quartic root of x cubed. Oh, I think I lost an x. Lost part of my x there. Okay, I think I was erasing stuff instead of pointing. Whoopsie. Okay, so it's back. So if we don't see an index, if there's no number given there, we assume that it's a square root. So it's not that we were lying to you about this being a square root symbol, it's just that there are a whole lot more radicals that we could have rather than just square roots. We could have cube roots or quartic roots or quintic roots, and so on. So to reverse this process, if I'm given something in radical form and I want to write a rational exponent, I'm going to take my index, pull it off the shelf, and tuck it back underneath to create a fraction. So it would be x to the 1/6. If I have a to the m over n, I pull that denominator out, put it on the shelf. I have the nth root of a to the m. If I have a rational exponent with a negative that is negative, well, the first thing I would do is make it positive by putting it on the other side of a fraction. So if it's on top, then we're going to flip it on the bottom. And if it's the only thing on top, then 1 remains on top. And a to the now positive m to the n is on the bottom. And if I want to put that in radical form, I take my n, pull it off the bottom of the fraction, put it on the shelf of my radical, and I get this nth root of a to the m. So if we're using one of these calculators and we want to evaluate roots other than square roots, we actually do have a button that does that, and it looks like this. Now to activate it, we first need to hit second, and then the caret key. Now the caret here lets us put in higher exponents other than just squared, and it also lets us, the second function, lets us put in higher indices other than just 2, so we can do more than just a squared root. So there's our rule. We can see formalized there. So this would be a good time. It says do it without a calculator. I am perfectly okay if you do this with a calculator, or you can use our toolkit here. So if I want to take 1 to the 1 or 100 to the 1/2, I would say that's the square root of 100. So I would look for the square root and I'd go down until I find 100, and then I'd say, hey, the square root of 100 is 10. Similarly, the 4th root of 16, I'd go to the 4th root, I'd go to 16, and then I go over and I go, okay, the 4th root of 16 must be 2. The 5th root of 100,000 is just good old 10. The cube root of 27, I'd find cube root, find 27, go to the left, cube root of 27 must be 3. So try the remaining 8. Give those a shot, and when you're ready, unpause the video and we'll go through them. Okay, and so here come the answers. Okay. So again, you can use the table here. I'm fine too if we're using a calculator. Okay, now we can have negative exponents. Just remember that it flips the position of the base in a fraction. So if it's on top of a fraction, it's got to go on the bottom. And if I take everything off the top, I've got to leave a 1. So if I have 10 to the negative 2, that'll be 1 over 10 squared, or 1 to the 100th. 16 to the negative 1/2, I'd have to write 1 over 16 to the half, which I could write as the square root of 16 to the first, which is 1/4. I lost my 1 somewhere. 1,000 to the negative 2/3. I'd write it 1 over 1,000 to the 2/3, and then I'd take the cube root of 1,000, and I'd get 10, and then I'd square it, and I would get 100. Now, technically, you can do this in any order you want, but I would strongly recommend always taking your root first, because it's much more likely to make it possible to find what you're looking for on the table. Okay. And if we do 5 to the negative 1/2, that'll be 1 over 5 squared, which is 1 over 25. So take a moment, pause the video, and try the remaining 8. Give those negative rational exponents a shot. See if you can evaluate those. And here's what we should be getting. And I would pause and check your answers there, and unpause when you're ready to go on. All right, and here is the homework. And with that, we'll see you in the next video.